Welcome to In 5 Minutes. Now I'll discuss about algorithm efficiency. Now as the name itself suggests, it's supposed to be a topic of analysis where we are going to discuss how efficiently any algorithm will work in a program to produce some result. When you're developing any computer program or application, you have to take different steps, and this set of steps is called as algorithm. To accomplish same task in a computer, we can take different set of steps. That is, we can apply different algorithms. Now it is our duty to first analyze all the algorithms which can be used to solve that problem or to write the program and decide obviously the best possible or most efficient algorithm. The efficiency of an algorithm stands for the amount of resources used up by the algorithm to perform some particular task. Now the resources used by different algorithms will be obviously different, so accordingly we can decide which is the best possible algorithm. The resources are categorized into two major forms or two major factors. One is amount of time required to complete the task, that is how fast an algorithm can produce a result, and the amount of space, that is the amount of main memory requirement of the algorithm. So when that program is working or when any algorithm is working, how much total amount of memory it will occupy. Obviously, we'll try and reduce time taken for algorithm to solve the problem or to complete the given task. Also, we'll try and reduce the space requirement of the algorithm. The program should take lesser amount of space, as much less as possible. Obviously, achieving both the tasks or achieving both the factors is a bit difficult, but we have to do some calculations, we have to decide check the current conditions of the system, current conditions of the computer, and accordingly we will decide which is the best possible algorithm. So we discussed there are different algorithms possible to solve any problem. You have to choose the best one. The efficiency of algorithm is decided by the amount of resources used by the algorithm, and it is measured using two different factors. One is how much is time required and how much is space required to perform a particular task. Next is what is time analysis or time complexity. Now it is really a big and complex task to do time analysis, and here we'll be discussing according to our syllabus what is time complexity is. It is measured using some typical scientific notation called as big O notation. It is made up of some kind of mathematics and some computer concepts. Here we'll try and analyze how much is the time required to solve any problem by a specific algorithm. Now if we use two different machines to run the same program, suppose one machine has, let's say, some 8 GB of RAM and some speed of 2 GHz, then the problem will be solved in some amount of time, let's say some n milliseconds. Whereas if the machine has lower RAM, has lower memory space and a low speed, same problem with same inputs will take more amount of time. So we cannot decide the time analysis just by the speed, that is some program works in, let's say, 3 milliseconds and some program works on another machine on 5 milliseconds. From that we cannot decide which algorithm is better. For that, what we decide is for given amount of inputs, how much time, that is how much period will be required to solve the problem in terms of the number of inputs, and it is not in terms of time, that is number of milliseconds or seconds taken by the problem. For example, let's say you are going to write some iteration statement that works for n elements to be processed, then obviously it will take n steps to solve the problem. The iteration statement will work for n iterations. If I use some other algorithm that goes for, let's say, nested iterations, that is nested loops, in that case it will take first outer iteration will take n iterations and the inner iteration loop will take again n iterations. It will be n square number of steps to be taken to solve the same problem. So obviously I'll choose the first one which takes n steps to solve the problem. I don't know really how much milliseconds or seconds or microseconds is going to take. It is how many operations the computer is going to perform depending upon the input data. So that is how time analysis is done. Second is space analysis. The space efficiency or space analysis is measured in terms of the total amount of memory space required to complete a given task by the given algorithm. Now here we consider the space required for the instructions, that is program and the instructions which will be stored in memory, then the inputs, that is values to be input for processing, the number of results to be developed after taking the inputs, the output data, and lastly the space required for calculations, because for doing the calculation there can be lot of memory required because there will be multiplications, squares, cubes will be done, and lot of memory space will be utilized and lot of time will be used. So that is how we do algorithm efficiency. Now let's take just summary of that. Here we try and analyze the best possible algorithm that will suit to solve our problem using least amount of resources, because there can be many algorithms that can be used for solving same problem. So you have to see to it that which is the best algorithm that uses less number of resources. We talk about algorithm efficiency in two factors or two terms, that is time and space. Obviously, as a programmer or as a user of any program, we should try and see that the algorithm takes least amount of time to execute and takes least amount of memory space to work. Time analysis, that is time complexity, is measured in terms of big O notation. Here we don't talk about the real time, that is time in terms of seconds or milliseconds taken by algorithm to solve the problem, but we talk about time as a function of input data, that is n inputs. For n inputs, how many steps a algorithm will take to solve that problem. For example, let's say finding a largest number out of n numbers. How many steps will be taken to solve that problem? Some algorithm will take maybe 25 steps, some algorithm will take maybe 100 steps. So it should be the function of input data and how many steps taken for that n inputs. Space efficiency is measured in terms of the total number of space taken by the algorithm to run. It is space taken by instructions and program, space taken by input data, space taken by the result to be produced, that is output data, and the space taken for the internal calculations. So that is all about algorithm efficiency. Thank you.